right? So this will be the coding part. Okay. So this is the coding part. Um, and usually the very first CNN with images, CNN is images kind of like, although you can use CNN for other things, but like right? It's a filter or an image, CNN images kind of go together. I recently read, that the Calix net became available, so that's a piece of history, right? So it's like literally the thing that changed uh, the world. That uh, CNN have already been in papers, I believe, well, what's neat this time around is he mentioned that said, and the guys at the University of Toronto had GPUs, back in 2012, 11, 2010, these were just used for gaming, and they somehow wrote the code or implemented the CNN to use that game as a competitive advantage. Anyway, so let's try the MNIST sample. So I'm going to close this link. Okay. I'm going to go back to Cipher and contents. We cover cross-section. We're doing good in all right, so M is here. Yeah. Now this one, with the 5.10, I gave you, I believe, a link to download the files. So you have to download the images, or, the actual images, read the images from a folder, load them in memory, convert them into tensors, do all of that, right? So you have that code. In this example, I'm just going to use a library in PyTorch and get the images from them. So essentially, just to make it a little bit simpler, but it's essentially the same. Now, one big difference that you have to consider when doing these things is that MNIST is the handwritten digits made famous by Jean LeCun. They're black and white. Essentially, Jean LeCun, who is now the lead person of AI at Meta, Facebook, he is chief AI officer. He in the 1980s, he worked in a project with the post office, United Post Office, um, or postal service, where they, how you write a letter, right? What do you put your address and then the zip code, right? And everyone writes that zip code, and everyone has different handwriting. And so all of us have different handwriting. So what they wanted to do, guessing, is they wanted to get a letter, have a camera, read the zip code, kind of redirect where that's essentially what they were doing. So they had a project where they wanted to create a machine learning model that could be the problem was that it was nobody became specific and you whatever you write down the so that's what they created. So they had a whole bunch of people write sevens and people write eights. So everything is just from 0 to 9. The numbers that you pieces of code and so John Code is tasked with creating a model for the United States Postal Service, which worked. And one of the very first examples of machine learning that actually was very, very efficient at doing the task. And that's why he's famous, created the distinction set, blindness, and so we're going to play. All right, so let's go ahead and start PyTorch here. Uh, oh, um, So, yes, so it's gonna be ITS for 65. Create a new format. Just gonna put CNNs. Conduct, environment. Was conduct activate. I think it's Pi 37 to 25. 365. All right. All right, so we should be there. So Jupyter Notebook. All right, so let's do new. All right, so let's build a network. Now, one thing that I can show you is whether we finish today or next time is I don't just want to do the CNN. I want to also process the image the way that you already know how to process with deep learning, right? So the first thing we're going to do is, or one of the things we'll do is build an architecture that's not a CNN. It'll just be an MLP or a two-layer deep learning architecture because you already know how to do that, right? You've done that for tabular data. You did that for the wine quality data set for iris, etc. So now we're just going to do this for CNNs. CNNs can be a little bit tricky sometimes because when you apply all the filters and then you create that hypercube and then you have to flatten it, you don't exactly know what that number is going to come out to be. So I'll show you how you can figure that out in a very easy way. But that's usually one of the hardest parts. And then the other part is, if it's black and white images, it's going to be, remember how images are going to be, if they're RGB, so they're going to be 28 by 28 by 3. If they're just black and white, 28 by 28 by 1. So you have to remember that. The tensor dimensions are really important here. But let's just get started, right? So let's just start playing with this. I'm going to call this one in-class MNIST. I call this in-class MNIST. All right, so rename it. Torch Vision might be something. Torch Vision is, as you might imagine, is a library related to Torch, but its own that has to do with vision things. Visions is like images. So if we need it, we can install it. So I'm going to copy the libraries here. All right, so we're using Torch, NumPy, the OS, Torch Vision for data sets and transforms. Transforms are things. So one thing that you might need to do. So let's say that ResNet was trained on images that are of size 124, right? But your images are 784. What do? You apply a transform. And the transform might do something like pad the image to be of a specific size. You see that and you solve the problem that way. All right, matplot and pill image. I think we've used this already, I believe. All right, so let's go ahead and run this one. It's thinking. Let's see if we need to install Torch Vision. Okay, but we don't have it, so we need to install it. There are frameworks for doing what I just discussed with transfer. I would state this pretty clearly. It's one of the rules of the game, right? Of the challenge. So there are other libraries, something called FastAI, that allows you to do transfer learning. However, that's not allowed for the competition. Okay, for the competition, you can use a ResNet, but only if you import it from PyTorch itself. Okay, you have to work it into your architecture, because the thing with FastAI is like it's really easy. And so I don't want you to use that one. I want you to. So that's one rule of the competition. All right, so let's go ahead and install Torch Vision now. All right, so it's installed. So now we run it again. All right, it finished it. Now let's go ahead and learn performance metrics. Remember that at the end of the day, it's a classification problem, just like line or iris, right? So we still want to measure performance with the same metrics that we used before. And remember that for the competition with Cyber 10, which has, I think, 10 classes maybe, you have to win the actual score all the time, right? So there you go. That's done. We have to train monologues, so we need the same things. So a lot of this is what I keep saying, right? So the moment we understood perception, already goals like 50%. Now that you know, or you know how to all these things, at least 70%. Yeah. We're still using a lot of the same constructs. And so, and then all of them for the right? Then some parameters, we're going to find some parameters here. So learning rate or nice. So it's going to be the learning rate 0.003. You can play with that. We're going to train it for 20 hours and that side is 30. So we give 32 images at one. So that's full of memory handle, but the PyTorch is made in such a way. So it's not an important thing. Not if you're training on MNIST or Cypher, you don't get all 60,000 images all at once. You can have enough memory. So instead, you have to do a batch of 32, train with that, then another batch of 32, and so on. And the weights are updated every iteration. All right, so we got our variables. All right. We have the path data, MNIST data. So this is where we can download information. So if you notice, I'm going to use data sets. So this time around, I'm not reading the data from a folder like in Cypher. Instead, I'm just, for convenience, using this library here from Torch Vision datasets. Okay. And datasets, and I say from there, I want to use the MNIST dataset. I want to use the train set, and I want to download it if I don't have it. All right, so I'm going to go ahead, and then it's assigned to MNIST train. So I'm going to go ahead and do that. So you can see it's pretty big, extracting, downloading, lots of things going on there. It finished, right? So I'm going to run it again. You can see this time it didn't do anything. It checks probably that it already has it, and then it doesn't do it if it's there. So that's your MNIST data. So we want to look at some of these images probably. They're very small. They're 28 by 28. And essentially, ResNets take images that are 300 by 300. So if you have 4K, 8K images, it's too big, way too big, right? So you have to use transforms to resize them to something like 300 by 300. That's the current state of the art. Someday, no doubt, 50 years from now or something, 4K, 8K will be fine. There will be some innovation, and who knows what it'll be like then. It'll create games probably that no longer look like games, right? They'll look like reality. So, but anyway, so now let's go ahead and look at the test set, for instance. So I'm going to go ahead and run the next one. So MNIST test, data sets, data path, train false. So now it's the test set. So this should be 60,000 to 10,000 images. This is the first large data set, right, that we've used all semester. And as we start to use CNNs, as we start to use large data sets of images, you'll see what happens to your computer, and this motivates the need for GPU. Okay, so let's go ahead. Now I'm going to show you this idea of transforms. All right, so I'm going to apply. So transforms are just a very convenient way of processing data. So it used to be that you had to do this processing manually, and it was really hard to do, right? And so now PyTorch, Torch Vision becomes so advanced that they make your life very easy. So you can see here now, we're going to take data sets MNIST, data path, train true, download, but we're going to add a few new things. The new thing that we're adding is this transform here. You see that? So it's got a flag in the datasets.mnist called transform. And what we add to it is transforms, which is from here, right? And it's going to give us a list of options. So we have many transforms. So we have an option called transforms.compose, which it's like a list of transforms. So for instance, you want to change the ratio of the images, you want to make them black and white, you want to convert them to PyTorch, you want to normalize it. All those things at once, right? In sequence. So you could use the transforms.compose to add that. In my example, I've only added one transformation, which is to tensor. Essentially, as the name implies, it's going to make the images into what? Into PyTorch tensors. So you have to do that in order for the images to run through the neural network. They have to be PyTorch images. So that's all it is. So now, MNIST train TR is essentially a PyTorch tensor. Okay. Now we're going to look at the next one. It's pretty much the same. So MNIST test TR is MNIST path transform, and transform use transform stock compose. And the only transformation that we're performing currently, but I left it like this because if you want to do another one, just comma in that one and then comma in another one. It just makes it easier. So now this one also converts images into Borg transforms. Okay, so now that you have that, we're going to proceed. You grab one of the images and look at it. Just gonna grab one image, display an image. So I'm going to use MNIST so this one, right? From MNIST get a component called .data, and I'm going to grab this one, two, three, that index. That image there, I'm going to convert it from torch tensor to a numpy array. And then once it's a numpy array, I'm going to use from kill image. And I'm just going to say image from array so that I can convert the numpy array into an image and display it essentially. So, let's see if it works. All right, there it is. So that's my image that you can see. It's a handwritten digit in this case. Cases. So usually images what they look like. This example we're reading from the library. We already have a torch tensor, and so now we just have to start creating the data loaders, and we're still going to use data loaders here, and then build our neural network architectures. Right? That's kind of so the next step, so we call printing the shapes is a good idea. We definitely print the shapes. So the demonstrating CR data by shape. If you notice, it says train is 60,000 by 28 by 28. So it's saying that it's 60,000 images by 28 by 28. It's still not forget about it. It's still retains Q, a tensor shape, and you should have a dimension comma 1 to indicate the channels are 1. That needs to be specified. Especially going to see it. Okay. We can do that for the test. And you can see this one is 10,000, 28. So that I'm going to have to sure why. Let me restart this. So let's run it. Hmm. Sorry about that. Something is going on. All right, there it is. You can see it created that data folder, right? So let's open this now. Yeah, so I lost, I guess, the shapes part. But let's run it again. Let's see. So we're back here. Let's just print the shapes of one. Right, so you have 60,000 by 20. Again, this is big. Start working on this now because, this is not, you're gonna have issues running this. Memory wise, especially once you hit a CNN. That's actually one thing that you will notice is if you build the deep neural network actually is bigger than CNN. CNNs are actually a little bit efficient, but they're still big, especially as you got layers. Okay. But a lot of this, especially with sci-fi, because it's in color, that's 28 by 28 by 3, 60,000 images. It's kind of hard to look at. All right, so with this part, so the next part is create data loaders. So as you can see, I've shown you, since the beginning of our discussion with PyTorch, we want to create these data loaders. Um, and we're going to do that. So really, I just have to show you and the data in MNIST is already formatted to fit directly into data loaders. But in the Cypher example, you'll see that you have to format it a little bit. So here we have, I already printed the shapes, we've done that, so then we can proceed to create our data loaders. So we have, all right, so batch size 32. Create a data loader, train DL. So notice torch.utils data.data loader. We give it MNIST train TR, batch size 32, and shuffle, remember, We just always want to shuffle the images. That's it. So this creates our data in a way that's easy to process for training. And then we have the test data set. Notice MNIST test TR, and the batch size is just 10,000. We don't have to give the data in batches here because we're only going to be using inference essentially. So we're not actually training and all that, which is much more memory constraint. All right, so we created the two data loaders here. All right, now we have our metrics function. This is the exact same function we've been using all semester. And there you go. Got a few more cells. Stay here. All right. So now that we've done this, guess what? We're ready to do the architectures, right? Oh, yeah. Do you have a question?
Oh, sorry. I might look at the test DL
Yeah, of course.
line. Right about the metrics.
This one?
Yeah, that's
What's your question?
in your MNIST C9 code, one you're doing right now on Jupyter.
Yes.
In between the batch size and the per feet. Yeah, right there. And
Okay. This was one line, one cell. I made it into two cells. But it's the exact same. Yeah, I could have done it either. Does that answer your question?
yeah, that's okay. Does.
Okay, great. So yeah, so notice I just 10,000, you just give it all 10,000 image, the model, and to remember your measuring performance. So when you guys do your challenge, can't stress this enough, you only train on this, right? And you never train on this. And instead, you measure the performance of your model on this, and you do it about 10 times. Take the average F1 score of that, and that's going to be your value for the competition. Whoever gets the highest on that is the winner. Okay. All right. So we got the metrics, we got a few things. So now we can notice we have gotten to the architecture. So here I have I only have one architecture, which is the CNN. But I can build other architectures, like multi-layer perceptron. So we'll probably do that on Wednesday. But yeah, so this is the idea. So we're going to need this little function. So we're going to use something called view. View is one of the ways, there's several ways that you can reshape an image. And sometimes we want to reshape our images, for instance, from 28 by 28 to 784, for instance, right? So we'll use this little function for that. But I think I'm going to hold off on this until this is a good stopping point. So, but just to show you what's left, we're going to pick up on CNN architectures. We're going to look at view. We're going to build the model, the classifier, and you'll see there's a different way that I'm going to do this, and I'll explain why. Then we have our train function. This is exactly the same. So essentially, this is the new thing that everything that I explained in the theory today is what we're doing here. You can see it's got one convolutional layer, a second convolutional layer, and then just looking forward. And then we have the training loop, we have the instantiation of the objects, and then we just train it, and measure performance. You can see what do you think about performance. But we'll play with this is MNIST, not PyTorch. So we'll play with this on Wednesday, measure performance with an MLP, measure performance with a TL of 2 layers, and then measure performance. Got it, guys? Sense? All right. All right. So yeah, so this is a good stopping point. I'll just pick up here on Wednesday. So we can stop here, and I'll stay for a few minutes if you guys have any questions.